So in Chapter 6, we're going to be looking at solving for equations, solving for theta, and you're going to treat any trig function of an angle like a variable, like an x or a y, and then solve for x or y, just like you've done before. It's just using algebra solving and then using your trig in order to identify what your angles are. You're going to have to remember reference angles. You're going to have to remember Santa Claus, which ones are positive and negative in the quadrants. You're going to have to remember reciprocal identities, some basic identities in the beginning. Ultimately, it's going to get into a little bit more tricky. So in solving equations, what you really want to do is look at the trig function of an angle and solve for that as a variable. And so you're just going to chip away. Like you could think about these, if it helps, as something like radical 3x minus 1 equals 0. And you would see if you were to solve for x here, you would add 1 to both sides and divide by radical 3. And then at that point, you'd have to get your answers. So if you want to replace an x from the cotangent theta, because it looks simpler or easier to follow, you can do that as an approach. But let's go ahead and look at the cotangent theta and solve for it. So you're going to have radical 3 cotangent theta equals positive 1. Do one step at a time on these. If you make one negative mistake at the beginning or in the first step, everything it follows is going to be off. So it's very important. Do one thing at a time. Don't do things in your head. Then you want to divide by radical 3, so you're left with cotangent theta equals 1 divided by radical 3. At this point, on your table, or I guess the unit circle you could go to and find this out, but usually we like dealing with sines, cosines, and tangents. Tangents are going to be the reciprocal identity here. So we're looking at tangent theta is equal to square root of 3 as it's equal to the reciprocal of the cotangent. At this point, you would go to your table or your unit circle to identify what the angles are. I like finding out the reference angle and then using Santa Claus to tell me what my angles are. So at this point, the tangent of what angle is equal to radical 3, and the answer is going to be 60 degrees, is going to equal your reference angle. Now, 60, the way I think about it, if I didn't use a table, is I know that the sine of 60 is radical 3 over 2, cosine of 60 is 1/2, radical 3 over 2 divided by 1/2 is radical 3, and so that's how I knew it was 60 without using a table. So I know that I have reference angle is 60. I then draw this to remind myself what quadrants this is in. So the tangent is positive, and this is going to be for 2 reasons I want to do this. And you want to do this. You want to get in the habit of drawing these things and showing them. Don't do anything in your head. Get it on paper. Reference angle is 60 degrees. I have to think about where the tangent of theta is going to be positive. I know it's going to be positive in the first quadrant, and it's going to be positive in the third quadrant. And so I know my reference angles are right there. At this point, again, sometimes it's in degrees, sometimes it's in radians. Looking at degrees, 60 degrees, I know my answer is going to be theta is equal to 60 degrees, which is the first quadrant. And then it's going to be 180 plus the 60, which is going to be 240 degrees. Now, that's not too bad in terms of figuring this out. This is going to eventually be just like one part of an equation because they're going to get a lot more complicated. So you have to know the basics to get started. Another question which is similar is solve for all solutions. So all degree solutions, it doesn't have this constraint between 0 and 360. You want to do it for all of them. That's where you have to deal with the K business. So, and this is what you look for is patterns of doing this. So when you look at this particular angle, you're looking for patterns, and you can think about this two different ways. If you get to this line here in the first quadrant and you go around, this actually is 180 degrees from here to here back up, because it's drawn the same line. It's a 60-degree angle. You have vertical angles there. So you would know it's 60 degrees. Therefore, the way you could write this is going to be, for all solutions, is theta is going to equal 60 degrees, which gets you to that first one, plus 180 degrees will get you to the second one, plus 180, plus 180, plus 180. You're going to add 180 each time, which means that you're going to have 180 degrees times K. K, this you don't have to write in for me. I'm going to assume that K is always going to be an integer unless you specify otherwise. Because in some cases, you're going to want odd integers, or every odd integer. But if you don't tell me what it is, I'm going to assume that it's an integer, and so I'm just going to write that off to the side. K is always integers unless specified. And one more time, an integer. Integers are 0, plus or minus 1, plus or minus 2, plus or minus 3, etc. So you can see when you put those numbers in, you're going to end up hitting all of the angles as you go around in either direction. All right, that takes care of the first of the three problems. Let's take a look at the second one. This is problem number 12 in the problem set. And it says 3 sine t plus 4 equals 4. The directions are solved for t. And we're now talking about radians 0 to 2 pi. Now I wanted to do one like this because it's going to tell you that not always can you just go to your table or to get your answers. There was a different way of doing this. And so when I look at this problem, I subtract off 4 from both sides. I get 0, and you divide by 3, and you get 0. And now the question is, well, what are my angles such that the sine of the angle is equal to 0? And the answer is where you actually can draw this to help you solve that. And I like drawing the graph. So when I draw the sine graph, I'm going to remember it starts in the middle and goes up. So I know it looks like this. And again, it's the 2 pi. That's my pi, and that's my 0. So my answer from this graph is where it shows where y is 0. Y is 0 at those points. Therefore, t is equal to 0 and pi. And I do not write down 2 pi because I see that it's just less than 2 pi. It's not less than or equal to 2 pi. So whenever you see an answer like here, which is 0, pi over 2, pi, 3 pi over 2, 2 pi, I'm going to draw a graph to pick the answers off of my graph. A lot of students will say, well, I just want to find my reference angle. Well, we don't have reference angles at 0, pi over 2, pi, 3 pi over 2. So I'm good on drawing those graphs. All solutions on this one. So another question, which is what are all the solutions in radians? Well, I can solve that as well, t is equal to, let's see, what's happening here is I look for a pattern. Starts at 0, goes to pi, 2 pi, 3 pi, 4 pi. I then can go ahead and recognize I'm adding pi each one, so it's really 0 plus pi times k, because I'm adding pi each time, which really is the same thing as pi k only. Third and last problem is going to be where it says number 17, which is find all solutions in the interval from 0 to 360 degrees. Use the calculator on the last step and write all answers to the nearest tenth of a degree, and then you have your equation. So the main thing here is, again, you want to solve and then use a calculator at the end for your answers. Calculators will give you reference angles. You have to be smart enough to know what to do with those reference angles then. Now, when you have the sine theta minus 3 equals 5 sine theta, this looks confusing, and what you probably want to do, or what you could do to help you, is just take your sine thetas and make them y's or make them x's. And then it can be a little bit clearer in terms of what you have to do next. So if you're seeing that and you're like, I don't know what to do on my first step, then what I would do is transfer it in terms of x's. So by transferred into x's, it'd be x minus 3 equals 5x. Now, if you had to solve for x, it's pretty easy. So I know that I have to combine like terms and then solve. So back to the original, I'm going to subtract sine x from both sides and get 4 sine theta on the one side. Notice I'm going to have a lot of steps here. It's often a good idea to put your equal signs and line them up just to follow your steps. Then I'm going to divide by 4. I'm going to get negative 3 over 4 is equal to sine theta. Now, when I want to get my reference angle, what I like to do is actually use a positive 3 over 4 to get my reference angle. So what I'm going to do is say, all right, well, the sine inverse of 3 over 4 is going to give me my reference angle. I know it's positive here. I know that's negative, but I remember on the calculator, if I always use a positive number, it's always going to give me that acute reference angle, which I want. So I'm going to go, let's see, 3/4. And we're going to go to here. Very important, you're going to be mixing radians and degrees here. You always want to check your mode, get in a habit of continually going to mode, make sure it matches. I'm in degree mode, happy with that. So I want the sine inverse of 0.75 positive, and I'm going to end up with 48.59, which is my reference angle. So reference angle is approximately 48.59. Now, one thing that you can do on the calculator, I may have a little bit of extra time today, so I want to show this to you. Eventually, it's going to be more important, but right now, it's so-so. As you can store this exact number in a letter, and then use the letter later on when you want to add or subtract something to it. So I recognize this is an important number. I have to do two things to it. So what I want to do first is store it. So the way to store a number is to go to this button above the on button and store. Store the answer in A. And so I'm just going to do greenie I'm going to do greeny. I'm going to do greeny A. Right? And then that's just going to store A, that letter A as that number, and then I can just use A in the future if I want. Okay, so back to the problem. I now have the reference angle stored. It may not be as obvious that you're going to use that now, but later on you'll see that is a nice feature. But I remember that I'm going to have the reference angle going back to this equation. It's the sine of theta is negative. That means it's going to be in the third and fourth quadrant, which means my reference angles are right here. So I want to take 180 and add A and take 360 and subtract A and my calculator, and I'll have my two answers. So I'll take 180 plus my A and 360 minus my A, and then I know that my theta is going to be approximately 228.59 degrees and 311.41 degrees. One last thing on this is I just want to show you, so I'm done with this, I want to show you how you would write this for all answers. And so to write this for all answers, we'll just do it up here. You have two answers, and so what I want to do is say one of my answers is going to go here, and then I'm going to add 360 to that one all the way around, and then the second one is going to go here, and I'm going to want to add 360 to that one as well. So in this case, you have to actually write it as two separate ones. So if the question were to give all the answers to this one, not confined to this or not to that constraint, you're going to want to say, okay, it's going to be 228.59 plus 360K. You have to write it out that way. It's not like it's folding on top of itself over 180. And then you're going to want to do the other one, which is going to be equal to that other angle, which is 11.41 plus 360K. So just another idea on writing all solutions. So you should be scored with that. All right, so you learned a little bit of a review in terms of Santa Claus, finding reference angles, using reference angles to finding angles, using your K form and integers to find all the angles, and so this is the basics. This is the very preliminary stuff, and we're just going to add on to it in the future.